Welcome to another GC Basic tutorial video. This is for the PIC16F175 chip family. This is part 8 of 20. So what are we going to be doing? We are going to be showing serial data. And there's good justification for this because this tests many parts of a developer's thinking, a way of showing information. So please like and subscribe this video. I'm in this for the like and subscribes. I'd like to get to 1,000 one day, so please subscribe. So using serial data to display values. So we're going to take some ADC values and we're going to display them on the terminal. This terminal is representative of any serial device. So it's extremely useful for communications. So I'm assuming that you've come here, you've installed the software, you've got some programmers, software working, that you've installed the 16F175 chip family. I'm using a 16F175xx. I'll show you that shortly. I've got a number of LEDs, a potentiometer, a switch, and now you have a USB TTL converter. I'll show you one of those very shortly. In terms of hardware, let me just bring the pen up. I've actually got a new connection. It's on port C6. That's where I will be transmitting data called TX1. TX1, remember that? Transmit. So it's down here. It's actually on the right-hand side of the chip here. It's this one here. And this will send data out. And we're going to pick that up in the USB TTL converter. So serial output. It uses the inbuilt universal synchronous asynchronous receiver transmitter. Quite the mouthful, or UART. USART is another name for it. EUSART is another, but it's a PIC microcontroller module that allows communications on the serial communications protocol. And I'm going to be doing it to a PC. So this builds upon the tutorials that we've done so far, plus this TTL USB serial converter. A USB converter looks like this. It takes TTL logic signals in and turns them into something our computers can recognize as a virtual serial terminal. And it has connected on it a number of connections, and the ones that we're interested in are the ground. You must have a common ground to the microcontroller. Okay, and we are going to send data out from our TX1, I believe it was called, and we're going to push it into the receive on here. If we were sending data, we'd actually connect one to the transmit line here and put that on our receive on the microcontroller. It works the same. You can pull 5 volts and 3 volts from this particular type of TTL converter. I don't do that because you don't really want to be pulling too much current down your USB port. So for today, I've got the ground connected and TX1. Let me show you my setup shortly. Now, we are going to have to learn some new techniques here, and it's called PPS, or Peripheral Pin Select. It allows you to change the port of the transmit onto a number of different ports. That's really different from the legacy PICs where it was fixed. You can actually choose which functionality you want on a wide set of pins. You can actually change it on the fly if you get really clever. We're going to put it in like a static. We're going to say we want to connect the TX1 to a particular port. And I've chosen, as I said, C6. So this gives you an increasing number of pinout options for a particular device. You can tailor your whole application around the configuration using PPS. You can say, oh no, I want it on a different port, and you just change to PPS, and that capability, in specifically we're referring to serial, will move to that port. So you could move it to C.4. I don't care where you put it. Today, C.6. So how do we do that? We must set the transmit using PPS. So what we've got is 2 tools. you can use. There's more than that in reality. You can use PPS tool, that's one of our tools, or you can use the microchip MCC standalone. A bit more complex, but I'm going to show you PPS tool today. Okay. So, what are we going to do? We are going to initialize. I'll bring my pen up. We're going to initialize the chip. We've seen that before. We're going to set up the serial. And in here, we're going to have to set up the serial, two components. Set up the PPS. If you don't set up the PPS, nothing happens. No magic happens. The chip assumes you've set up, it's not my microchip assume you've set up PPS. If you don't set it up, it will send data into the module. It just won't be connected to an output port. So you must set up PPS and tell it the baud rate, bits per second. I've chosen 9,000 bits per second. You can go up, choose whatever number you like. I don't care. Then we're going to loop forever. We're going to read in the ADC like we did before here. We're going to send some data out to the serial. And if it changes states, we're going to display that. So all it's going to do is loop around forever. It's going to loop around, send in some serial data. Oh, let me put it on there. Send values to serial. Fantastic. And that's all we're going to do. Let's have a look what we've got. Let's have a look at webcam. Let's have a look at desk cam, as I call it. Right, this is desk cam. Here is my selected. Here it is. That's my selected one. Now, in this, it's slightly different from the PowerPoint. Doesn't really matter. But I've got a yellow line connected here and a green line. I always use yellow for transmit, by the way. You'll find out I use other colors as well. Can I zoom in on that for you? I think I can. Whoa, look at that. Look. Yellow is connected to the, there you go, RX, D, RX on here. Just I was having a look myself, and ground. And where's that connected to? On the board, we'll have a look at that. We'll just slide the camera to the right. That is my ground there. You can actually see written on it ground, and the yellow is connected. Let me just move that for you to C.6. That looks like C.7, but that is purely a parallel. It's connected correctly. Now, what am I going to do next? So what I'm going to do, I'm going to plug in the TTL for us. I'm going to plug it in. Pop. I popped it in my USB port. Nothing's happening because it's empty. There's no code in there. So let's go and have a look at some code, shall we? Press the Windows key. I am going to start up GCStudio, GCStudio. Probably we're going to see, oh, no, we're okay. Now, I've been doing some other stuff here. I've been looking at the digital libraries, and essentially what I'm going to do though is I'm going to select the 16F175xx chip family demonstration. So click on that and away we go. It opens up the IDE. No, it doesn't, not on your screen. On my screen it does here. I'm going to shut down that bottom terminal window by pressing Control J. Now, so let's have a look where we are. I'm going to open up the demonstration. Control B opens up the list here, and it says reverse. Here, look, there's lots of things, lots of files. So remember, if you click on that, Control F, type in GCB, and then this down arrow, this down triangle, it will filter. Here we go. I'm going to select reversible LEDs. That's a demonstration of 100. Now I'm going to close down the Explorer window. Great. So I'm going to walk you through the, let me show you what it's doing first. How about that? And then we'll have a look. Okay, so we suck the file in, press function key F9, and it will open up a terminal, a serial terminal. Here it is, a serial terminal. This is a serial terminal. And if I just pop back and program this, I think we'll get some action. Now let me just, I think how I'm going to do this, because I want to do many things at the same time here today. Right, I'm just going to program it and then toggle back to the terminal. There we go. I might change the fonts in here. We might have to change the fonts to make them a bit bigger. And then we'll explain once we've seen what it does. Okay, I'm in the terminal. Let me zoom in on that for you. And I will bring this up so that you can see explicitly what I'm doing. So I've opened up the terminal by pressing function key F9. You can get to the same thing by pressing function key F4 and selecting terminal. I'm going to scan or rescan my computer, and I've got two communications ports set up, COM1, COM5. If I unplug that USB TTL converter and I rescan, I have 1. If I pop it back in and I rescan, I will see COM5. That tells me that's COM5. Now, it's been programmed and it's running, therefore we're going to get some instant results. And we got some instant results there. Look. Back to the desktop. We're getting some instant results of 107. Just so you can see, there's some hexadecimal values on the right-hand side. I'll just turn those off for the distraction point of view. Let me reset that font a bit bigger for you. There we go, 107. Now that's popping away, and I'll clear that down. 107, 10. And if I come into the camera, let me just try and sort out all this for you. As I rotate the potentiometer, you can see the value is first of all, it's moving to the left. If I push the button, that's the same demonstration as yesterday, moving to the right, and it has a value of 25 to 200. And if I pop that button, changes direction. So something is putting that on the screen. That's what we're doing. So we're sending data from that port here, down that yellow wire, into that TTL converter. The terminal is then picking that up, and the magic is happening on the computer. Fantastic. Let's have a look how we go about doing that, shall we? So, first thing we need to do is set up the chip, which we've done, hash chip 16F175xx. Option explicit, we need to declare our variables. First thing we do is we set up our PPS. I put my PPS code here. Let me just delete that, and I've taken it out. It's gone. Honestly, nothing would happen. If I reprogram it now, nothing will happen. PPS, really important. So to get to setting that, let's bring up PPS tool. So I'm going to press function key F4 and type in PPS, and it lists the top option, PPS tool user. Select that, and it loads in some XML files, and it brings up this user interface. I'll zoom in and bring that in for you. See if I can zoom in any more. Oh, look at that. That's perfect. Now, here's the chip selected, and here are all the chips that you can select, and there are many different chips, but I've already pre-selected mine. And I want to select an output, so it's a PPS output. There's a drop down here. If I cursor down to the bottom, you can't see it because I've zoomed out too much. I'll do it again, zoom out a bit. There we go, you can see it now, TX1, transmit 1. I need to allocate that to a port, so I'm going to allocate that to C.6. Is that where I've got it connected? C.6. I was just looking at my source code, and then I press the add button. And what the add button does, it generates some code for us. It generates code, it's a code generator. Copy that, copies into your clipboard, back to our editor, IDE, click it, and just Control V. It puts in the code for you. It sets everything up. Let's look what it's doing. It's created a subroutine. It's called init PPS, and it will set the PPS, the capability, the module, or the enhanced USART to that particular port. That's exactly what it does. Now that port is being controlled as a USART port. A couple of things above it, okay? We set up a a constant. That's just for reference. But this is important. Hash startup. It says run this init PPS, which is the automatically generated subroutine at startup. When the microcontroller starts, it will run this routine. It has to do it early because you might have, let me just think, you might have some debug that you want to have shown early on in the process. So this is a very early process. So you can set something between 0 and 100, but 85 is good for PPS. Okay. There are other things that need to be initialized, but you can play with that second number there. It will ensure it goes in the start routine. So it will do the initialization, and then the next thing that will happen will be init PPS. Really important. And it's these numbers here. You can go to the data sheet and cross-reference them. We've seen this diagram before. I've added in the TX1. Nothing has changed in the general code apart from this here. Look, I go set up the serial port. I define. Oh, that's wrong. Look, I'm going to put that up. Connect via PPS. Connect via, because that's ambiguous. Putting down a port number. USART. So you have to give it a baud rate and then a value. And it's a good idea to say transmit USART transmit blocking. What does that mean? It ensures that each byte being sent on the serial line has been fully transmitted before it sends the next one. These microcontrollers are very quick and you can overwrite the buffer. So that stops that from happening. Let's pretend for a minute that you don't remember what all that commands are. It's really hard to remember all this. Well, let's just delete it. And in this IDE, you can go underscore and then just type U, and it will say UR setup, USART setup. And it automatically inserts the code for you. So you don't have to remember, you can go to the help. Let's just do that again. Underscore USART. I don't know if you actually just type USART, it will not. No, it will give you the syntax lot for it will give you the constant, but underscore USART, bang, it generates a code and lets you change the number. So these little macros are quite useful. So transmit blocking, and you can put delay. I've turned it off. Okay, all right. In here, the default turns it off. So very simple. So how do we actually output stuff? Well, if we're using this particular module via PPS, we use things like H serial print, hardware serial print, and there's lots of different commands. Go and look at the help. H serial print. So if I press function key F1, it will take me to H serial print, and in here are all the hardware commands that you can use. It's from get a number, print something with a string, receive something, send something, lots of different things. But what I'm doing is I'm saying send a carriage return line feed, print a string, GC Basic 2025. Put the string name on there. At is a string. Chip name, chip megahertz, sorry. And then a string of chip megahertz and wait for 2 seconds. But we didn't see any of this. I'll tell you why we didn't see any of this. Because we weren't looking at the terminal when it all kicked off. Let's have a look. We'll just wait in this terminal now to see if all that strings come up. Oh, they do look. That's great. I'll just disconnect. That's fantastic. Because look, what we've got is GC Basic 2025, the chip name at 32 megahertz. Oh, yeah, that's cool. So if we change the megahertz, which we've never actually done, we change that to 4 megahertz, or reprogram it, go back to the terminal. I'm just going to connect it, clear it. It's just programming it. Okay, good. It now says same chip at 4 megahertz. The serial still works because all the back end of the compiler works out all the bits that need to be set for you. So there's no calculations like that. You just tell it the baud rate and it will work. So if we put that back to 32, which is the default, and we come into here and we put that at, let's go into my terminal, see what the terminal can cope with. I'm going to put it at 256. Oh, I did that wrong. 2560000. Is it 3 zeros or 1 0? 2 zeros. 3 zeros. Good. Function key F5 into the terminal. Change the baud rate. Clear the terminal. Connect it. 1, 2, and it puts it up for you. So now the terminal's running at nearly, well, 256,000 bits per second. And it's still doing exactly what it was doing at 9,600 BPS. So I put it at 9.6. Do you know why? Because I know it will work on most computers, and that's the only reason I do it. Now, back to our little program here. I said wait for 2 seconds. That's just so we can read it in our brain, okay? And then how do we actually put these things on the screen? Well, it's pretty obvious. If the direction is right, then put a string out. And if it's going to the left, it must be the other side. Put the, oh, look at the little typo. Tidy that up. Less than L, and then a tab. H will send. 9 is a tab. Put that value on. So look, you can a print can handle different types. So I'm sending it a number here, and I'm sending it a string here, and it would typecast it for you. And then I'm sending out a character return line feed. Function key F5. Back into the terminal. Change this to 9.6. Clear the terminal, and we should get exactly what we saw before, but at a slower baud rate. There you go. And as I rotate this, you can't see me rotating on the camera. Maybe I should bring the camera up. Here we go. I'm not going to explain to you why that's 25, because you can see it on the screen to the left of the terminal. The range I've selected is 25 to 200, exactly what I expect. Now, there's no jerry rigging going on here. This is working exactly as it should. So, really simple. Read the data in, use H serial commands, job done. You can do exactly the same using software. And we have a set of software serial commands. Quick look at that. Control B. I've put one in here for you called 103 reversible serial terminal. And this is actually using software. No PPS. We'll just program it, see what happens. Bring the terminal up. I'll explain it in a moment. So this is using just software. Bit banging is another name for it. Let me just figure out why that's not working. Have I got it set up properly? Disconnect. Definitely. I'll just rescan, make sure it's all good. No idea why that's not working. Because the TTL's working. Use hardware. Oh, it is working. It was my error. It was my error. Just me panicking. There you go. So if I push the button, it goes. Now, these use very similar commands, but as you can see on the left, it's serial 1, serial 2, serial 3, and serial 4, and they're software, no PPS involved. But generally, I would advise you to use the hardware if you can. It's far more, it's faster, etc. Look, in the top of here, there is no PPS. Look. but it's exactly the same port, but we're bit banging it out. So I put that in here, and that's demonstration 103. Now we're getting quite a few things on the screen here, but in the library, in the storage. So I'm just going to clear it out. Function key F4, type in CLE, and it says clean solution. And it will clean the solution. What that's just done, it just tidies up that folder. So if we look inside of here, again, I can get rid of the filter, and the only things I've got in here is GCB files at the moment. Now let me just compile something up, and it will populate it with all the files it's generated. And we'll look at those later on in another video. But if I press function key F4, take the clean option, it just deletes those files for you, tidies it up, tidies up the system. Highly intelligent. So what have we seen? We've seen PPS tool, we've seen terminal, we've seen hardware and software serial. Fantastic video. Next time, we're going to move on. We're going to look at timer overflows using 8-bit timers, 16-bit timers to flash those LEDs. Up to now, we've been using this wait command. We're going to change the process, and we're going to look into timers. After that, by the way, we turn left, we don't use the LEDs. Enjoy.